Hello there. In this video, I'm going to talk about rolling update deployment strategy. It is a zero downtime rollout. You start replacing existing pods until you have no more pods to replace. The benefits of this approach include rollouts can be paused and resumed, rollbacks are straightforward, rollouts are slow and controlled. With this approach, you have no control over traffic. You don't know how much percentage of the traffic will be sent to the newer pods. It can also be problematic if older and newer versions of your apps cannot function together. Rollouts can also be slower with this approach. Rolling updates use readiness probes to check for the availability of new pods. In case of a problem, a rolling update can be aborted quickly without bringing the whole cluster down. In this sense, it is a controlled way to release new features. Rolling update is one of the default deployment strategies in Kubernetes. You don't have to do anything special to make use of it. All you really need is a code snippet similar to this inside your application YAML file. Max surge and max unavailable are two flags used to manipulate rolling updates. I will talk more about them during the demo. Let's visualize a rolling update. We have a Kubernetes cluster with a couple of active pods. As part of the deployment, we would add a new pod. This new pod is now running a newer version of application. As we progress with the rollout, we will keep adding new pods and removing old pods. Finally, we would reach a point where we have no more pods to replace. Let me further explain this with a demo. As part of the demo, I'm going to deploy an application, start a rolling update, roll back the deployment, start a new deployment, pause the deployment, resume the deployment, and validate version 2. Finally, I will start best effort controlled deployment to demonstrate max unavailable and max surge flags. Let's get started. I'm going to deploy version 1 of my application. Let me run a command on a terminal window here. So you can see a service and a deployment object was created. Now let's observe this. Let's see what happened here. So on a different terminal window, I'm going to run watch command. So you can see a bunch of pods here. So in my YAML, I'm defining 10 pods. So you can see 10 of them are all active running here. Now let's validate the application. So this is the command that actually talks back to my application. It prints the host on which the app is running. This is the pod, and this is the version of application. All good so far. If we examine our deployment, we can see 10 active pods. Now let's see how they change during an upgrade. I'm about to start the upgrade. Please pay attention to the white terminal window. Notice that Kubernetes added a new replica set here. All the new pods will be added to this replica set. Also notice that the current set of pods that are in ready state are 10. But the total number of pods in desired state are 11. Why is this discrepancy? Why the number in the desired state higher than ready state? To understand this, we need to go back to our YAML. As you know, rolling update strategy is defined in our application YAML and is controlled by max surge and max unavailable flags. In our YAML, we have set max surge to 1. This means we want Kubernetes to add pods one by one. Max unavailable is set to 0. This means we want Kubernetes to keep all 10 pods active during the rollout. This is why the desired pod count was one more than the running pod count. And as a result, Kubernetes did not reduce the overall capacity of the cluster during the upgrade. As you can see, all 10 pods are now active in new replica set. This means our deployment is done. Let's verify. Here you go, we can see application version is now 2. We have successfully upgraded our application. Now let's say we found a bug post deployment and need to roll it back ASAP. No worries, we can quickly undo a rollout. Let's get started. So this command is gonna initiate the rollback and we'll go back to the previous version one pod at a time. Let's verify if the rollback is working as expected. So I'm gonna launch a curl command here. So you can see that one pod actually a couple of pods are already rolled back to version 1. Actually more than a couple of pods are already rolled back to version 1. So you can see the rollbacks are really easy and simple with this approach. Now let me demonstrate a different kind of a rollout. As part of this, I will start an upgrade and then quickly pause the rollout, verify and then resume. Such rollouts are required when we need to bake things in production. So let's get started. I'm starting this rollout. Since I don't want to upgrade all the pods in one go, I'm going to pause this rollout. Alright, so let's verify. So you can see there's one pod here which got upgraded to version 2. The rest are still on version 1. That's exactly what we wanted. So we pause the rollout so we can bake our host in the production and see how it behaves. Alright, so if we check again, we would still see the same result. So we only have one pod which is on version 2. There it is. And the rest are all on version 1. Alright, so assuming everything looks good at this point in time and we are ready to go, we would then resume the rollout. And this is the command to resume the rollout. Okay, done. Now let's verify. You would see slowly more and more pods will start to show up version 2. If I look on this other screen here, you notice 2 pods are on the new version, 8 are still on the older version, but 1 should be coming out soon. So yeah, so now we have 3 pods on new version, and slowly but surely all of them will move to newer version. Next, I will demonstrate best effort controlled rolling update. In this approach, we will use percentage values for max surge and max unavailable flags. As you see, we have set max surge to 0 and max unavailable to 20%. This means 20% of the pods will be unavailable during the upgrade. As a result, the upgrade will go faster with this approach. Let's see how it works. I'm starting the upgrade. Please notice with this approach 2 pods will be rolled out at a time and total pods will never exceed 10. As a result, the total capacity will be lower than 10 during the upgrade. Also, the rollout is faster as we target more pods. Let's verify. You can see more and more pods are now running version 3. That's all about rolling update strategy. Next time I will talk about canary deployments, so please stay tuned. Thank you for watching.